Assalamu alaikum everyone. I hope you all are fine. So now today we are going to attempt question number 7 taken from exercise 7D from Think Book 3. Let me just mention it on top as well so that you will get to know that from which book we are doing this exercise. Think Book 3 exercise 7D and we are attempting question number 7 now. Let's start reading the question to get to know what information is given and what to find. A storage tank consists of hemisphere and a cylinder which share a common base. I hope you must have understood till now that what does common base mean. Common base mean that if the diameter or the radius is given for any shape, so it means it will be replicated for the other shape as well. So if the diameter of the cylinder is 4.7 meters, likewise the diameter of the hemisphere is 4.7 meters, and it will be definitely leading towards the same radius. The tank height is 16.5 meters as shown in the shape or figure as well, and the cylinder has a base diameter of 4.7 that I have already discussed with you. Find the capacity of the tank. So what does capacity mean? Capacity means volume. So you have to find the volume of the whole tank, which is consisting of two shapes. One of them is a hemisphere, which is the top of the shape, and the bottom is cylindrical shape. Let me just draw it for your convenience, like how does a hemisphere look like if it is not attached with any other shape. So the top one is the hemisphere and this is a cylindrical shape, and the parts which I am coloring are attached with each other to form a different shape as shown in the question. Now, let me tell you that common base means, as I have already explained, means the diameter of the cylinder and the diameter of the hemisphere is similar, 4.7. So if the diameter, this is the diameter, right, as shown in the figure at the bottom of the cylinder, this is 4.7. So this is diameter 4.7 meters. So R is the half of the diameter, which becomes 2.35, and radius is always started from the center of the base, and it moves, the line moves towards in any direction touching the outer curved part of the base. So this is the radius. Likewise, if I draw a center point on the base of the hemisphere and drawing a line moving towards the outer curved surface of the hemisphere, it is known as the radius. Now the radius for hemisphere and cylinder are same, so I'm writing it 2.35 meters along with the radius of the hemisphere as well. The height of the full tank, including the cylinder as well as the hemisphere, is given as 16.5. So we don't know the separate height of the cylinder, because for calculating the volume of the cylinder we will be needing a separate height of the cylinder, not the full height of the whole shape. So let me tell you how to get the separate or individual specific height of the cylinder. Let me just draw with the green color. We focus on the hemisphere part. This is the hemisphere radius as shown, 2.35 in a horizontal line. Likewise, in a same way, if I draw a line starting from the center of the hemisphere, and leading towards upward like this. This is also the radius of the hemisphere, right? So if the vertical line is also a radius of the hemisphere, so it means that this line, which is making a 90-degree, can be considered as the height of the hemispherical part. So if the hemispherical part height is 2.35, so we can just get the exact height of the cylinder by subtracting it from the whole height of the figure. So this part which I am highlighting with green, see, this is the green part, and exactly parallel to this part which I am highlighting on the red arrow. This is 2.35, right? This is 2.35. And the whole height of the shape is 16.5. If I need to find the specific height of the cylinder, I have to just subtract 2.35 from 16.5 to get the exact height of the cylinder. So this is how we can get the height of the cylinder. So I am writing it here as height is equal to 16.5 minus 2.35, and it will give me 14.15 meters. So we have calculated the height of the cylinder so that we can just enter the specific height in the formula for volume of cylinder. Now we have to find the capacity of the whole tank. So there are two shapes. So we have to find the volume of hemisphere first and then find the volume of cylinder. The answers of both volume will be added and then we will get the total volume or the capacity of the tank. Let me just start writing on the right side. Okay, so capacity of the tank, or you can write volume of the tank. Capacity of tank is equal to hemisphere plus cylinder. So formula for hemisphere is 1 over 2 4 by 3 pi r cube plus volume of cylinder is pi r square h. As we know that hemisphere and cylinder are sharing the common base, it means the radius for both of the shapes will be considered as same 2.35, and the height of the cylinder we have just calculated 14.15. So 1 over 2, 4 over 3, pi will be punched in the calculator, and r is 2.35 cube, again pi 2.35 square along with 14.15. This step is left for your calculation, and after adding up the answers of both volume of hemisphere and cylinder, you will get your final answer as 273 meters cube. And I have rounded off to three significant figures, so no worries about it that if you are not getting the exact answer, your answer could be in decimals nearest to 273. So this is for all now. I hope you must have understood the concept of finding the capacity of the tank, which is made up of two different shapes. So the most important thing is that you must know the exact formula and the all requirement which is supposed to be filled in the formula. So take good care of yourself and wait for the next video for question number 8.